In this video, we are going to look at the quotient rule for differentiation. Now, we understand that quotient means division. So we have a function given to us in the form of a fraction, where we have one function being divided by another. So if we have y is equal to f over g, then y prime is equal to f prime times g minus f times g prime all over g squared. Now, another way of remembering this rule is we differentiate the numerator and we multiply by the denominator. We put a minus sign. We keep the numerator as is. We differentiate the denominator, and for the denominator of this answer, we square whatever the denominator was. So we have f prime times g minus f times g prime all over g squared. So let us look at an example and see how to apply this rule. Say we have the equation y is equal to, and we are given 2x plus 5 all over 3x minus 2. Now, as a starting point, it would be good for you to identify exactly what f and g represents in this case. So we've got the numerator representing f, the denominator representing g. That just makes it a lot easier for you when you are about to differentiate. So we're going to have y prime is equal to, so we have f prime and f is the numerator. Differentiating the numerator, the derivative of 2x is 2, the derivative of 5 is 0. We are going to multiply that by the denominator, and the denominator is 3x minus 2. Then we put a minus. We keep the numerator as is, that is 2x plus 5. So we have f times g prime, and we differentiate the denominator. Now, to differentiate the denominator, the derivative of 3x is 3, the derivative of minus 2 is 0. So it's just being multiplied by 3. And the quotient rule tells us that we square the denominator. So we're going to have g squared, which is going to be 3x minus 2 all squared. So that is our first step for the quotient rule. Now the second step is for you to just simplify what you have and gather any like terms. So we're going to take this 2 and multiply into the bracket with both the terms. 2 times 3x is going to be 6x. 2 times negative 2 is negative 4. Now here, the 3 is going to multiply into the bracket and the negative as well. I'm just going to do it in 2 separate steps. So first, let's multiply the 3. We've got 3 times 2x, which is 6x. We've got 3 times positive 5, which is positive 15. Now there is no need for you to square the denominator. You can just leave the denominator as is, where you have the square outside the bracket. You don't have to expand it. Now in the next step, let's take that negative in front of the bracket and multiply into the bracket with both terms. That is going to give us negative 6x, and we've got negative times positive 15, which is going to be negative 15. We'll keep the denominator exactly as is, 3x minus 2 all squared. Now gathering terms, like terms in the numerator, we have 6x minus 6x. They cancel out with each other, and we've got negative 4 minus 15, which gives us negative 19. So we are just left with negative 19 in the numerator, and the denominator will remain as is. So this is going to be our answer for y prime, negative 19 over 3x squared. Let's look at another example. So example 2. We now have y is equal to, we've got x plus 1 all over x plus 2 to the power 10. So just reviewing our quotient rule, we understand that our numerator is represented by f and our denominator is represented by g. So it helps a lot if you can label your numerator and denominator, just so that it's easier for you to keep track of what you're doing as you are applying this rule. So y prime is equal to, remember it's f prime times g, so we're going to differentiate the numerator. The derivative of x is 1, the derivative of positive 1 is 0, so that just leaves us with 1. F prime times g, we're going to keep g as is. Then we put a minus sign, we keep the numerator as is, so we keep f as is, and we now differentiate the denominator. So we differentiate g. Now to get g prime, something you need to understand about g prime here is that you will have to apply the chain rule. And reason being is because we have an exponent outside the bracket, so we have to differentiate according to the exponent first, and then we have to differentiate according to what we have inside the bracket. So we've got two functions. There's a function outside the bracket and then a function inside the bracket. Differentiating outside the bracket first, we're going to have 10 times the coefficient. We know that if there's no number in front of the bracket, we take it as a 1. So it's going to be 10 times 1, which is 10, and we minus 1 from the exponent. So the exponent is now going to be 9. Now differentiating inside the bracket, the derivative of x is 1, the derivative of 2 is 0. So this is what we have when we have applied, and we can actually make a note of it. This is what we have once we have applied the chain rule to that denominator. Now, part of your quotient rule tells you that you square the denominator. Now, in order for us to square this denominator, if we're just going to look at this separately, right? We've got x plus 2 to the power 10, and we want to square this denominator. That's going to result in these two exponents being multiplied together. So it's actually going to end up being x plus 2 to the power 20 once we square that denominator. And that just comes from laws of exponents, which you've learned in high school. Now, to simplify the numerator, we've got 1 times the first bracket, so it will stay as is, x plus 2 to the power 10. Now we can actually multiply any constants or any coefficients. We've got 10 times 1, which is going to be 10. And we've got this bracket of x plus 1, and we've got the bracket of x plus 2 to the power 9. And we've got our denominator, x plus 2 to the power 20. Now, part of simplifying is for you to factorize if possible. If you look at your numerator, you've got two separate terms, and both terms contain brackets that have x plus 2 to the power of something, where the first term has x plus 2 to the power 10, and the second term has x plus 2 to the power 9. Now, what is common between both terms is x plus 2 to the power 9. So we can pull that out as a common factor. Now, what we are left with in the first term would be a bracket of x plus 2. And in the second term, we are left with minus 10 into x plus 1. And in our denominator, we've got x plus 2 to the power 20. Now we notice that based on the bracket that we factored out, it is common with our denominator. So we can simplify. And according to laws of exponents, we know that if we are dividing bases that are the same, we can subtract the exponents. What is going to happen is 9 of these brackets are going to cancel out at the top and at the bottom, which means that at the bottom, we are left with x plus 2 to the power 11. So basically we have cancelled out. So this has cancelled out from there and we were left with 11. And what is left in the numerator, we can actually simplify this. The first bracket we have x plus 2. Let's now take this negative 10 and multiply into the bracket. So we're going to have negative 10x. And we've got negative 10 times positive 1, which is negative 10. Let's gather like terms. We've got x minus 10x, which is negative 9x. And we've got 2 minus 10, which is negative 8. The denominator will stay as is. We cannot do anything with that. So this should be our final answer for y prime. Minus 9x minus 8 all over x plus 2 to the power of 11.